Today we're going to be looking at how we deal with all these different representations of lines and how we can sort of work in between those different forms to benefit us. Okay, so we're talking about all of our linear equations and we sort of want the equivalent representations. Maybe this is an E or an I. I'm not sure on that spelling right now. It's been a long day and I can't remember how to spell. Okay. So when we are looking at equivalent linear representations, there's one that we already definitely know for sure. Okay, and that's one we've already talked about, and that is that we definitely know that we can go from standard form and we can turn this into slope-intercept form, right? Where when we are in standard form, this is a nice option for us to be able to find the x-intercept and the y-intercept. Okay, and next week as we sort of do this and work with this some more, we're going to talk about when that might benefit us, but the x-intercept and the y-intercept are always sort of our starting and our ending point of a graph. So, right, if you think more about when we're relating graphs to events, right, it's where we start and it's where we end. And so there are often times that these two are really important. Okay, but we might decide, you know what, the starting and the ending point aren't really what I'm looking. I really would prefer to have the slope. I want to know that rate of how that time is changing. Okay, and so if we want to go from standard form to slope-intercept form, we've already talked about the fact that we can solve this for y. And we've been solving for y for so long, I hope it's kind of like you're solving for y in your sleep at this point. I guess maybe that'd be a little bit weird, but... Okay, and when we solve this, right, up here we were in standard form because x and y are together. Down here we are in slope-intercept form. And now when we're in slope-intercept form, right, now we are able to find the slope, which is something we weren't able to find before, right? Here we can find the slope and we can find the y-intercept. And so the y-intercept is the same either way, right? If I cover up and divide, I'm still going to get a negative 15. But up here, I could find the x-intercept. Down here, I now can find the slope. Okay, so when we are in standard form, okay, we're able to find the x-intercept that we can't find in slope. And in slope-intercept, we're now able to find the slope, which we weren't able to find in standard form. Okay, but what happens if we want to work between some of the other forms? Like, what happens if I want to go in reverse order? What if I'm given slope-intercept form and I have something like y equals 2/3 x minus 4, right? Now I can find the slope and the y-intercept, but what if I want to know the x-intercept, right? I want to know that starting point. Well, I would need to, again, take advantage of my skills with literal equations, right, and moving things around to get it in standard form. In standard form, I want my x and y together, which means I want to get my x back over here with my y. So just like my normal solving skills, right, to move across the equal sign, I'm going to use the opposite sign. So I'm going to subtract this 2/3 x from each side. So I'm going to put my x first, right? Because in standard form, we want ax plus by equals c. Now, unfortunately, standard form really does have some pretty particular rules. Okay, the real true way that we write standard form is that a should be positive. Okay, and a should be not a fraction. It's like anything else has the freedom to be whatever it wants. We don't want any fractions for my a and b, and we want our a to be positive. Okay, c over here can sort of do whatever it wants. Fraction, negative, positive, it's fine. Okay, so to get rid of a fraction, right, if I want to get rid of this denominator of 3, I'm going to have to multiply by 3. But remember, multiplication and division are something that happen all the way through the entire thing, which means I need to multiply each individual one by 3. Now, I also am not allowed to have a negative, So I'm going to multiply by a -3 to make a negative times a negative a positive. Okay, so you can either use your calculator or remember -3 times 2 gives me -6. -6 divided by -3 gives me a +2. -3 times 1. And a -3 times a -4 gives me a +12. Okay, and so 2x minus 3y equals 12 is giving me the exact same equation up here. It's representing the exact same thing. Okay, it's the same linear function. It's just representing it in a different format. Okay, let's say I have something in point slope form. So let's say I'm given y minus 3 equals -2 times x minus 5. And let's say I want to turn this into slope-intercept form. Well, to turn something into slope-intercept form, right? Slope-intercept form is y equals mx plus b. So I want to solve for y. So again, our literal equations, right? If we want to get y by itself, I could just add this 3, but if I just add this 3 over here, right, I can't do anything with this stuff inside. So to get to slope-intercept form, I need these parentheses to be gone. So I'm going to go ahead and distribute. A -2 times a -5 gives me a +10. And I'm going to undo subtracting 3 by adding 3. So I have a -2x plus 13. Just be really careful with your signs here, right? If this was a -8 plus 3 or something, right, you have to make sure this sign goes with this number. Okay, so now I went from up here I had point slope, and now here I have slope intercept. Okay, so now we have enough information to kind of get mostly wherever we want, right? If I'm given point slope form, I can get to slope intercept form, which means if I'm given point slope form, I can't talk today. If I'm given point slope form, I could take it to slope intercept form, and then using the rules I learned about taking slope intercept form to standard form, right? I could then move this over and turn this into standard form. So I can get from point slope to slope intercept to standard. I can get from standard to slope intercept, and from slope intercept to standard. But we're missing the one small piece of how are we going to get to point slope when we're given something in slope intercept. And the answer is I don't actually have the best answer for you. There's several options that you can go with. And this was the dilemma we were talking about in class with point slope form. Point slope form can be represented in multiple different ways. Okay, so there's gonna be options. You might be talking about the same linear equation as a neighbor in point slope form, and it could look totally different. Okay, it is the dilemma of point slope form. However, if we just want to get something into point slope form, here's my suggestion. If we have standard form and we want to go to point slope form, my suggestion is that you solve for y and get it into slope intercept form, because that's something we're already good at. And we already did this one up above, so I'm not going to finish, right? Solve for y. So I'm not going to, right, work. And you'd get y equals 3x minus 15. Then when you're here, there's two things that we know. We know that the slope is 3, and we know that the y-intercept is -15. Now remember, the y-intercept is the point where it crosses on the y-axis. And this is really an ordered pair, where the x value is 0 and the y value is -15. Okay, and so what happens is that this gives us our y coordinate, And we're just going to always fill in our x coordinate as 0. And so we'll have y minus negative 15 equals 3 times x minus 0. Now, hopefully you go, okay, well, 2 negatives make a positive. So that takes care of that. And maybe if you take a look up here, you start to sort of see a pattern, right, of where these numbers went. Of what we really did was just move this 15 over here with the y, right? So that became a y plus 15. And then I just filled in these parentheses with it being with a 0. So if I have something like y equals 2/3 x plus 9, and I want to go into point slope form, I can really just subtract this 9 over and know that my x coordinate is 0. Now again, this isn't perfect because this is a way. It is not the only way. Some of my students might say, well, Mrs. McKinney, couldn't I graph this equation and then go up 3 over 1 and then use this point and plug that into point slope form? Absolutely. Could I find my x-intercept and use that as a point and plug it into point slope form? And nothing says you can't. Okay, so this is giving you an option. It's not perfect. What I want you to consider is that it's not really important as to how point slope is represented. It's more important to recognize that each of these forms we're looking at are giving us different information. Okay, they're telling us different pieces that we might want to know. So if I say, what things are we able to find in standard form that we can't find in slope-intercept form, we should recognize, oh, the benefit of standard form over slope-intercept form is that now I am able to find the x-intercept. I lost being able to find the slope, but I am able to find the x-intercept. Okay, so for your assignment, you're going to be doing a little bit of flipping between different forms, but also talking about and responding to what things you can find that you might not be able to find in different forms.